Hello everyone and welcome to DTS Programming. My name is Daniel and today I'll be presenting my project linked list for my CSC382 course at the University of Advancing Technology. For this project we had to create a linked list, implement a doubly linked list using a template. Of course we couldn't copy any code from another source, and we were to include the ability to find data, to insert new data, to delete a node, and for extra credit, minimum and maximum values. So let's jump over and look at my program real quick. Alright, so you can see here I've created a menu option just for quick testing. It says, welcome to the linked list generator. Please select from the options below. And for the first and second option I have at 1, insert a head node, and 2, insert a tail node. For these are all display options. Display the current list, display the list in reverse, display the current node count, and display head and tail values. And down here we have search for a specific node or delete a specific node, and then our exit option. So what I'll do is I will go ahead and show that there's currently no list created, empty list. Please create a new node. So I will go ahead and insert a head node. And here it says, please enter any numeric value to store in your new node. We'll do 12. And there you see that I entered 12, and now the current linked list for node 1 is 12. I showed the head and tail. You can see that both values are 12. The one node is set as the head and the tail currently. Let's do option 2 and enter a tail node. That means I will enter a node after the head or at the end of the list. And you see we now have 12 and 54. If I do another head node, that value is entered at the front of the list and it is set to the new head, and the other nodes get pushed back. So I will go ahead and add a couple more nodes. There we go, and our linked list thus far is 9, 12, 54, 99, 57, and 86. And so you see our node 1 and our node 6, 9, and 86. And if I go ahead and display the head and the tail, you see the values 9 and 86. Again, my list in order: 9, 12, 54, 99, 57, 86. Or I can display in reverse order, and I created this option just to show that as a doubly linked list it can be traversed in reverse. And there you see 86, 57, 99, 54, 12, 9. And the current node count is 6. We'll go here to number 7, search for a specific node value. You can enter any value at this point. I enter 99, you see node 4 is 99. If I enter a value that does not exist, specified value 5 could not be found in the linked list. And you see node 4 is 99. And we can delete a node. I display the current list. Let's delete the head, which is value 9. Node 1, please enter the node number that you would like to delete. You selected 1. Is this correct? Yes, it is. And now you see 12, 54, 99, 57, 86. So now 12 is the new head and 86 is the tails. Continues to be the tail. So if I go to 6 to display head and tail again. Now you see the new head value is 12 and 86 is the tail. And I can delete a node from anywhere in that list. We'll take out the middle node, node 3, which is 99. Yes, that's correct. And now you see the list at 12, 54, 57, 86. And if we display the node count, see the node count is now 4. So that is my program for creating a linked list and displaying the values forward and reverse, displaying the node count, displaying head and tail values, using an option menu, searching for specific values in the list, and deleting nodes from the list. It's a simple program. Of course, if the list was much, much greater, I would use other methods, but for this simple demonstration, that is the program that I have come up with. So we'll go ahead and exit and we'll take a look at the code. Starting with my main, what I did is I just made a program driver that pretty much runs the program. So for main, I create a program driver object called program, an instance of program driver, and I call the main menu from my program driver. And starting with the main menu, I store a user option. While that option does not equal 9, which is my exit, this program will continue to loop. Clear the screen so anytime it comes back to the menu, this is all we'll see. And then of course my options. So I'll take in the option from the user here, and then I call a method to verify that option. In verify option, we pass in the option that was selected from main menu. This first check is to see if that option is an integer. If it's not, so if not option, then we'll clear cin and ignore the values, and then we will prompt for another value and take in the new value. If the option is an integer, while the option is less than 1, which is 0, and greater than 9, so anything after 9, so anything that's outside of my option menu, then we will clear and ignore cin, we'll notify of invalid option, and we'll take in a new option again. And this will loop until the option is between 1 and 9. Moving down the page here, still in verify option, I go into a switch case, which actually decides what happens when the option menu is, or the option selected is actually correct. So I did a switch statement, passing in an option. For case 1, we will enter node data, and we will pass in the option number, and I'll show you why I did that. So you'll see in case 1 and case 2 is the same, but where it differs is actually inside this Internode Data method. So in this Internode Data option, here we store data value, clear the screen, so this is the only menu showing. Please enter any numeric value to store in your new node, and then it takes it into the data integer. So this is getting the value from the user. And again, this while loop will run while that data is not an integer, so if they put anything else other than a number, it will prompt to please enter a numeric value and then take in a new data option. And here's where my switch case comes in. So for the first two options, which are to insert node at head and insert node at tail. So to pass in the option, if it's option 1, we go to case 1, which is insert node at head. And then this data that was specified by the user gets passed in. And then again, if the option that was passed in is 2, then case 2 will insert node at tail and take in that data value. And then here's my verification. You enter this number. It will show that this is the current list. It will display the list, which we'll get into once we get to our doubly linked list class. And then it pauses the program so you can see what the values are. All right, back to the option menu for case 3. Instead of creating a method, I just did a little quick block of code here. It'll clear the screen, current linked list, and it will display the list. For case 4, same thing, clear the screen, reverse linked list, it will display, it will call the reverse display from my double linked list class. And case 5, clear the screen, show that we are getting the current node count, and then call the getListSize method from doubly linked list class. And very similar in case 6, it will get the head value and the tail value and display both of those. For case 7, search for node value. We got an integer that stores the node value to search for. Clear the screen. Please enter the value you would like to find that gets taken into the node value. And then we call find node value from our doubly linked list class and pass in the value specified by the user. And then for our case 8, we have delete node. We have a integer to store the node choice, char which stores a y or an n for yes, no. Clear the screen, display current linked list, takes in the node number specified by the user. So verification, you selected the node option that you passed in, and then it just asks if this is correct, yes or no. If yes, or if the yes no value, the char value equals n, then we will recursively call this method again, delete node, so it'll just come back to the top and prompt them again. So it won't do anything, it'll just display this again. And so once the correct value is entered, the yes no char is yes or y, then we will call the delete specific node method from our doubly linked list class and pass in the node choice specified by the user, and we will display the list again. Then of course, for our exit, when the while loop ends, here in our main menu, you'll see that there's nothing else there, and so the program will terminate. So let's go into our node class. This is pretty simple, fairly simple. We have some data int, and then we have a node pointer to next and a node pointer to previous, and then we have some constructors for our node. This default constructor, it just initializes data to equal 0. And so if a node is created with no value passed in, then the data will be 0 in that node. And here is our main constructor that takes in the data value, and it sets this data to equal the passed in data. Now, here's where all the fun happens. Starting off, we have our get new node. This is part of creating a node for our insert node at head and insert node at tail. So we'll start here at insert node at head. So right at the start, we create a node pointer. It is called new head node, and it is set equal to get new node with the passed in data from the user. And so get new node, as you can see, this is a node pointer function, so it will return a node pointer value. And so here we set node pointer called new node equal to a new node object. And then we initialize those values. New node dot data equals the passed in data. New node dot prev or previous will be equal to null, and new node next will be equal to null. So what you see here is a node is being created. It gets passed the data that the user selected, or the user passed in here, goes through here, and then the next and the previous will be set to null because there will only be one node there, so there will be nothing to before it or after it. And then it will return that new node. So once that new node value, new head value is set to that new node, then we do a check if head equals null, then our head is set equal to the new head node. So if there isn't currently a node there, there is no head, then the head becomes this new node that we just created. If there is a head value already, then we set the head dot previous to the new head node because this is insert node at head, so we want this to go before whatever current head that is already there. Then the new head node next equals head, so this, not the head yet, this is the new node we just created, and the next node is set to the current head. And I'm new at this, so it got a little bit confusing. So diagrams are definitely your friend when dealing with linked lists. But anyway, we put a new node in front of the current linked list, in front of whatever node is already there, which should be the head node. It's at the front of the list. And then we set the next pointer of our new head node equal to that head. So this value is now what this value was. And then head equals new head node. So this is saying, okay, now you're the head. New head node, you are now the head. And so that effectively puts a node in front, gives it the head address, and then sets it as the new head. After we do that, we create another node pointer called temp. We set it equal to the address at head. And then we check while temp.next does not equal null, so meaning we're not at the end of the list, then temp will equal temp.next for each iteration of the loop. So what this is doing is it's taking the address at temp and it's setting it to the next node and the next node and the next node until it sees that the next value is null. So this basically puts us at the last node in the list, and once we're there, we set tail equal to temp. So we set tail equal to the last node in the list. And then we increment the list size because we just inserted a node at the head. All right, insert node at tail is very similar. First, we create a node pointer called new tail node, and we get a new node with the passed in data. and our null references at previous and next. Again, we set this node pointer called temp to the head, the address of head. Another check if head equals null, head equals new tail node. How can the head equal the new tail? Well, if this head check is null, then that means there are no nodes. And so, this is being the first node created, it will actually be the head and the tail, even though we haven't set the tail yet. So, there will be a new node. Even though we're inserting node at tail, there's no nodes created, so it's the only node there. So, we set it equal to the head. Otherwise, if there is a node there, then while our temp, the next node for our temp address does not equal null, then again, temp will equal temp.next. So again, with each iteration, our temp address will move to the next node until it's at the end of the list. And then here we set the tail equal to temp again. So if there's only one node, then we will see that it is the head and the tail at the same time. After that, we set tail.next to new tail node. So we're putting in a node after the tail. New tail node previous is equal to tail. So this is saying the node prior to the new tail node is that tail value. And then we say, okay, now the new tail node, or tail is equal to the new tail node. So we make that new tail node the new actual tail. It sounds crazy when explaining it. But it all makes sense. As you saw, the program runs smoothly. And then here again, we increment the list size because we've inserted a new node at the tail. All right, and delete specific node. Again, very similar. We create a node pointer called temp1, set it equal to the head address. We check if the node position, so if the node position is passed in by the user, so they've defined which node they're going to delete. If the node that they want to delete is 1, which is the head node, then head equals temp1 next. So it's setting the head address to the next address after temp1. So the next node in the list. And then it frees that temp1 address. So it deallocates that block of memory. If the node position is anything other than 1, we have a for loop that will iterate through the list, and it will go to the node position -2. So this is the node we want deleted. Let's say it's node 5. This will take the pointer to node 3, and then it says temp1 equals temp1.next. So it says node 4 is now temp1. Then we create a second temp node pointer, and that is equal to temp1.next. So temp1 is node 4, temp2 is now node 5, the node that we want to delete. Then we set temp1.next to equal temp2.next. So we want the next node from node 4 to now be node 6. That's the node after. Temp2, remember, was set to the node to be deleted, which is 5. So we have node 4, we want the next pointer to point to node 6. So when we delete node 5, that link will still be established. And then we free temp to, which is the node to be deleted. Node 4 connects to node 6. And then we decrement the size, the list size. We just deleted a node. This is better if I show a diagram. But for the sake of this video, I'm going to say if you need that diagram, search it up on YouTube, link lists, deleting nodes. There are very detailed explanations out there. But I'll run through it real quick again. Temp 1, node position -2. So if that node is 5, we set to node 3 the address, and then we set temp 1 to the next address after 3, so it's 4. We set a second temp, which is set to the next node after 4, which is 5, or the node to be deleted. And then temp1.next equals temp2.next, so temp2.next is node 6. Node 4.next is getting set to node 6, and then node 5 is getting deleted or free to deallocate that block of memory. Here we're displaying the list. We're taking a current node count, or we set a current node count equal to 1. Again, we create another temporary node pointer equal to head. If temp equals null or if head equals null, then we display this is an empty list, please create a new node. Otherwise, while temp does not equal null, or while temp has a value, we will run through the list, and for each iteration we will display, or we will see out node with the current node count, and with each iteration the data will be the next node and the next node and the next node. And so going down the list, it will show node, current count, current node count will increment, and then it will show the data for that node. And then I create an extra line there just to make everything look good. Reverse display is very much the same. Temporary pointer, current node count. If the head doesn't exist, again, empty list, please make a new node. While temp.next does not equal null, then temp equals temp.next. So this is basically, we started at the head value and then it's going through the whole list. So this is putting the pointer at the last node in the list. And I'm doing an increment count as I go. So we know exactly how many nodes are in the list at this point. And then I do a reverse list. While temp does not equal null, we're at the back of the list. We will see out the node with the current node and the data contained in that node. And then we will set temp equal to temp.previous. So it will traverse backwards and show the data for each previous node. And then we do a current node count, which was incremented here. We decrement it here. So if there's 10 nodes, this will be 10, and then when it displays it in reverse, you will see node 1098765431 in reverse like you saw when we ran the program. And finally, for our find node value, with a passed in value, we have an int setting current node equal to 1, an int that stores data set equal to 0, and a boolean for value found, and that is set equal to false. And so like all the other methods, we have a node pointer that is called temp set to the head value. If temp is null or head is null, then this is an empty list. Otherwise, we go to a for loop that will go through the size of the list, the current size of the list, which is stored here in our private member variables. If temp does not equal null for every iteration, it's going to check, and then data is going to equal temp data. So the data integer here is going to store whatever value is at that current node. So if the passed-in value equals that data, then we set the Boolean flag value found to true, and we display the node with the current node and the data that was found. And I didn't show it, but I will. I'll run the program again at the end. If you have multiple values that are the same, it will display each one of them. So I'll demonstrate that here in a minute. All right, after that runs, temp equals temp.next, so it'll go to the next node value, and our current node count will increment. Or if the passing value doesn't equal any of the data, then this value found will never be set to true, and so it will still remain false. And if that value is still false, that Boolean is still false, then you will get the message specified value not found in the current linked list. And if that flag was set to true, here at the end of the method, I set it back to false so that everything runs properly in the next go round. And here are some of my getters that aren't over here because I defined them in line here. Get list size, return this list size. Get head value, return head data, and get tail value, return tail data. So whatever the head or the tail is at any point in the program, it will pull it from here, whatever the list size is, with all my increments and decrements, then it will pull it from here. So, going back to the program one more time. Currently empty list, create a new node. You see all my error checking is in place. So now you see my list has two 23s in it at value at node 3 and node 7. So let's display or search for a specific value. We're going to search for 23. And there you go, node 3 and node 7. Both have a value of 23. So we don't want that. We don't want two of the same value, so I'm going to delete node 3. There we go. Display the head and the tail, 8 and 23. What's our node count now? Node count is 6. And that is my program, and this is my project link list for my CSC382 course at the University of Advancing Technology. Thank you.